2, 1.
Whoa.
Oh, whoa, whoa. That kind of flew like a dragonfly.
Still going.
That is so cool.
Oh my god.
Still going
Oh
on.
no, not the tree.
Is he going to get out?
Hi, it's Slater the Science Toy Maker. In this video, you'll find instructions for making a flying machine that'll go higher than the tallest trees.
Oh, there it goes.
You can build it with a kit that includes such things as model airplane rubber bands, which store far more energy than regular office rubber bands. These tools will help you. You'll also need a 2-liter bottle for making your own propeller, and for the body, either straws or food packaging foam. And by far the most important thing is your attention and time. With some experience, you might make a helicopter in 10 or 15 minutes, but this first time, when everything's new, allow at least an hour of following directions. Experiment after you get yours flying. There's some amazing science to explore when you build your own helicopter, especially Sir Isaac Newton's 3 laws of motion and the ocean of air that is the troposphere that we live in. Because you can adjust the propeller angle, you can experiment with crazy things like flying the Dragon upside down. If you want a wind-up helicopter that's much faster to make and easier to make with younger kids, then check out this design that uses an already made propeller. It doesn't go as high, but it's quick and easy. So what if you don't want to buy anything, even if it's inexpensive? We'll cover some tips for making a basic helicopter just with stuff lying around the house. If anything's not clear, remember there's a linked web page with lots more details, and feel free to contact me if you have any questions. Straighten the aluminum wire, if necessary. If you printed out the PDF pattern, now's a good time to make sure that it's printed to scale. Cut off a 5 centimeter piece of the aluminum alloy wire. Aluminum is softer than steel, so you can use scissors. Grab the very end with the very tip of the needle nose pliers, not part way into the pliers, and not sticking out. Bend 90 degrees, pushing at the wire right next to the pliers so that's a sharp bend. Here's a side view. If you do it right, it should be close to this pattern. Push the tip of the pliers against the first bend and bend 90 degrees again, always applying force close for a sharp bend. Bend yet again, and you have an offset square. Make it a centered diamond like this. Grab here inside and bend 45 degrees. This wire is the propeller shaft. Don't lose it. Take the cotton off the swab stick by twisting at the end of the swab. Unfortunately, some are very difficult to get off, but I've been experimenting. Dipping in water makes the cotton much easier to remove. Dipping in hot water is even better. Look close and notice the tiny channels melted into the ends that helped keep the cotton on. Center the stick on the pattern. Mark to get a 13 millimeter section in the middle and equal length pieces on the sides. Cut straight across, not at a slant. Slide this small section on the wire shaft. Slide 2 of these tiny seed beads on next to reduce friction. It's really easy to lose these. Hold this red tubing on the pattern with the concave inside curve on the bottom. With the end lined up with the pattern, make 2 marks. Cut off on the second line. Use a push tack to punch a hole at the mark in the middle. Push the wire shaft with all the other stuff on it through in the same direction that the tack went through. We need a bit of wiggle room, so we'll slide the red thing so the stick goes to the hook. Then grab the wire with the very tip of the needle nose pliers. Push the wire over applying pressure close to the pliers for a sharp 90-degree bend. The space created by the plier tips gave us our wiggle room. Push it together and wrap a piece of tape tightly around several times. Cut off the extra wire and tape. Remember the tiny channels at the end? That bumpy end needs to go into the red sleeve because the little grooves provide just the right amount of friction for adjusting. It should spin freely. I'll use a green bottle for the propeller blades. Might show up better on camera. If you're just making one, use this pattern lengthwise like this. But if you're making lots, use this bulk pattern. Cut near the ends. There might be a bump that rings the bottle, right where the widest part starts at the bottom. Line up the edge there. Rough cut the bottle, starting the cut with a razor. We'll flatten and split the strut end for strength. Put the stick into the flat of the pliers and squeeze hard to flatten the end. It's dangerous to cut toward fingers, so wrap a rag around so your fingers are out of the way of the razor. Make 2 cuts at the bends, splitting 2 flattish flaps. There's an alternate method with scissors if you're dead set against using a razor. The propeller attaches in the middle and goes straight. The top of the tape lines up with the top of the strut. If you put the tape on gently at first, then you can adjust it straight before sticking on hard. Tape the other side too. Cut off extra and cut off triangles of tape, corner to stick. The outside corners are sharp, but just cut off a tiny bit. If you want to pre-adjust the blades now, the wire is below. The concave inside curve faces down. Then the blade that's close to you tilts the right side up about 22 degrees from horizontal. Or use the gauge. A little air should make it turn like a windmill now, but don't clock the person next to you. This is the mother of all rubber bands. From one end, cut a piece 28 centimeters, which happens to be the length of North American printer paper. Tying is easy but confusing the first time. The overhand is the simplest knot there is. Just make a loop and put the end through. But we put 2 ends together and treat them like one strand. So here goes. Rubber band ends together, loop ends through. Pull a little tighter, gently. Hold inside the loop, right next to the knot, and pull. The knot actually moves toward the end. This does not work with regular rubber bands, but this special stuff for model airplanes is amazing. You can make the fuselage out of just about anything. Recycled foam trays, drinking straws, bamboo skewers, etc., as long as there's space for the hook to spin. We'll start with plastic straws because they're ubiquitous throughout the world. Measure the long, not bendy part of 2 straws to about 14 centimeters, although it's okay if there's some bendy part at the end. Tape the ends together. Whatever you use, the propeller shaft has to be spaced about 3 millimeters away from the body so the hook has room to turn without rubbing. I glued this one on without a spacer, and the propeller cannot turn freely. Fortunately, remember you can always remelt hot glue with the tip. Make sure that you're using one of the lower temperature glue guns. So this time we'll cut off a square of the spacer material. Glue it to the not bendy end of the straws like this. Tack on the hub so that some sticks out on both sides. Then cover it with a thin layer of glue. Spreading a thin layer of glue makes a strong connection, but making a thick blob just adds too much weight. It's really important to not get glue on the ends where it could rub against the wire. If glue does get on, find a way to get it off. The rubber band hooks onto the front. The knot always goes in the back, and will make a back hook from part of another swab stick. It's a good idea to slant the stick slightly this way so the rubber band doesn't fall off. Spread a thin glue layer for strength. The knot always goes in the back. Without any wings, the fuselage just spins too fast and doesn't fly. So put a wing in between the straws. If the wing is too loose, tape the straws together around here to make a tighter fit. Bending the wings up gradually is called dihedral, and it adds flight stability. Splitting the wings is optional. You can also decorate. The gauge can help you start with a propeller angle that gives you good flying. The concave or inside curve faces down. The gauge is parallel to the straws. The end of the blade that is facing you should line up with the gauge. You can fly your Dragonfly now, but check out the flying tips to get best results. I like recycled foam grocery trays and takeout containers best, but they're not available everywhere. I do not like the ones with bumps because they're not as strong. There are lots of ways to cut the foam. If you're making a lot, hot wire cutting is fun and fast. But scissors or razors work well too. Some trays have thick foam and others thin. This one is strong enough even when the rubber band is pulling. But this one, yikes. Foam that's 6 millimeters thick might be okay with a strip 2 centimeters wide. If it's thinner foam, you might have to make the strip 3 centimeters wide to get enough rigidity. Or you can tape together 2 foam strips. The stiffness is a function of the square. Even though it's only 2 times thicker, it's 4 times stronger. This thin foam from a takeout container was not strong enough even with 2 layers, but 3 layers worked. If it's too flimsy, just add another layer. Same as the straws, the fuselage is 14 centimeters long. Cut a square piece from the spacer strip and glue it on. Center the little tube on the square and spread a thin layer around for strength. Again, don't let glue get where it'll rub moving parts, or get it off if it does get on. By the way, you can use the curved edge of the tray precisely cut as the spacer instead of the glued-on square. The easy way to attach the rubber band in back is to cut 2 little slots, 1 centimeter apart. The knot always goes at the back, away from the propeller. A hacksaw blade also works well to cut the slots. The wing goes on about 25 millimeters from the front end of the foam with 2 pieces of tape. Bending the wings up gradually is called dihedral, and it adds flight stability. Splitting the wings is optional. As with the straw fuselage, this gauge can help you start with a propeller angle that gives you good flying. You can trace the angle on. As the propeller faces you, wind up clockwise, a lot. The first 30 or so turns don't do much. You can wind more than 150 turns. The reason these Dragonflies are bouncing around is the propellers are not balanced. It'll still fly okay, but to balance, take off the rubber band. The heavier side will always go down. Either cut a little off the heavier end or add some tape to the lighter end. Either way. When you want to see the highest it can go, rub some baby shampoo, soap bubble solution, or even just soap lather or liquid soap into the rubber band. It makes it more slippery, so you can wind it more and store more power. Also put something soapy slippery in the hub bearing to reduce friction. To make a helicopter fly upside down with the propeller on the bottom, twist so the concave side also faces down. Assuming you wind it up the same way, the left side tilts up about 20 to 25 degrees. Avoid extremes of heat and cold. You can't wind it up as much in cold weather. Do not store the rubber bands in sunlight. You can send time-release gliders up in your helicopter and make the auto-gyro returns as detailed here. If you use a geared winder, not only can you wind faster, but you can put more twists in and therefore more energy because the rubber band is stretched out at first. If you wind this way, you might want to make this kind of hook with a swab stick in the back. You can repair the wings with tape if they break. If the wing keeps breaking, you can substitute one made from a foam plate. They're heavier, but they're also more durable. If this worked well for you, please spread the word of a good science project. If it didn't work well for you, please contact me, Slater, and tell me what's happening so we can get it flying. So maybe you can't, or you don't want to buy the kit. That's okay. But the most important part of the kit is the special rubber band made for flying models. I've experimented with everything, even making rubber bands from bicycle inner tubes. The fact is, Super Sport rubber, made specifically for flying models, holds many times more energy than the office or school rubber bands. Why go through the trouble of making a great machine only to power it with a low-quality rubber band? You'll also have to use a heavier steel paper clip for the propeller shaft, straightened out. Bend the hook, as per the previous instructions. Cut a 1 centimeter piece of cotton swab stick and slide it on. Instead of the tiny beads to reduce friction, you can make a washer from a scrap of the bottle. Make a hole with a tack and either punch it out or cut it out. Put that on. Cut another swab stick to 5 centimeters and mark a hole in the middle. Punch the middle hole and put that on the paper clip too. We'll use the same spacing trick as before when making this bend. Cut so there's about 1 centimeter remaining, but don't use scissors for steel paper clips. Tape as before. But now we have to set a good propeller angle. I used to glue it on with a jig made from straws, but had problems with the hot glue warping the propeller. So now I use a 22-degree pattern. Tape the lower jaw at the flat part. Put one end to the other side of the pliers. Then rotate left so the shaft is parallel to the pattern edge. When you squish the stick now, it'll be at a good flying angle. Cut the slots in the end and tape, same as the variable pitch design. From here on, the propeller is the same. I've tried everything I can think of to get more power from regular office and school rubber bands. With regular rubber bands, I get a burst of power, but it's very short. I liberated the thin rubber strips from an old bungee cord. I was hopeful, but they only worked slightly better. Just switching to Super Sport model rubber gets the Dragonfly many times higher, and it stays up many times longer. I mentioned that making wings from foam plates or takeout trays is heavier than the wings in the kits, so they don't go as high, but they're also more durable. Grocery store trays are even thicker and heavier, but you can experiment and maybe you'll find a good way to use them. I've also made wings by shaving weight off of bamboo skewers with paper. Doesn't it remind you of a bat?